Hi there, and welcome to my first lecture on weather. I'm going to start by describing how weather is affected by solar radiation. And so we're going to start really big picture in space. And to start us off on this lecture, first let's read the objective together. Students will be able to explain how the tilt and shape of the Earth changes the distribution of sunlight on its surface. So if you're looking at this with notes that you got because you were absent, then those are the words that you would fill in on those blanks. The first blank, tilt and shape of the Earth. The second blank is sunlight. Okay, so moving on. I ask students to describe what they already know about weather and what they wonder about weather. And lots of people talked about precipitation and rain and that weather changes very rapidly. Sometimes it doesn't change for very long times. And lots of people also wondered some great things like how do clouds form? What causes rainbows? And something really important right now is how or why are tropical storms like Irma so intense and why are there so many hurricanes in these past couple of years. So that's getting into our global climate change talk, which won't come for a little bit, but we are going to get to that eventually, and we're going to be able to answer those questions as scientists. The next is a demonstration. So I'm going to pop over to another room where there's a light and a ball that I can show you a demonstration with. So first I'm going to turn this light on. Okay, let the camera adjust a little bit. I'm going to turn this light on, and I'm going to hold this ball up, but I'm going to squish it so that it's more of a spherical shape, kind of like our Earth is. And so I'm going to hold it up to this light, and I ask, what do you notice about how the light actually hits the spherical shape, and what do you wonder? So what I notice, and what I would prompt the class to kind of observe, is where is it brightest, and where is it dimmest, and where is it kind of in the middle? So if you look, and even though there's that seam right here, that's not really actually causing that shadow. As you can see, if I move it, it's still pretty dark on this side. And just due to the shape of the object, the light will be highlighted on the side of the object where the light is coming from, and then shadowed on the other side. And so it's something that we, would see in our everyday life that we might not think twice about, but in terms of the physics of how weather works and how the sun is lighting up our Earth, that's something that we have to notice and we have to think about. Where is the sunlight going once it hits the surface? Because as we see here on Earth, there's an atmosphere, there's mountains, there's pavement, there's rivers, all these things that this sunlight is actually impacting. And how much is it? You can see the reflection here. This is actually bouncing off. Is there actually reflection off of the Earth into space? And we're going to see that, yeah, there is. And what influences that? Okay, and then we read this together. And just in a second, I'm going to be popping on over to a PowerPoint. Okay, so we're going to read this together and we're going to annotate together. And we're going to make sure that we highlight our new vocabulary words. So first, weather is the state of the atmosphere at a given time and place. Most weather takes place in the troposphere, the lowest layer in the atmosphere. So our first new word here, weather, is, we're going to circle is because we're going to indicate how we know it's a definition. So here's our vocabulary word. Here's our indicator, and then we have the definition. So how do we know what the definition for weather is? Well, it says weather is, and then it defines it. Most weather takes place in the troposphere. So that's another new word. Shown that it's going to be described by the comma, and then we underline the definition. The lowest layer of the atmosphere. Weather is described in a variety of ways by meteorologists, scientists who study and predict the weather. Air temperature and pressure, the amount and type of precipitation, the strength and direction of wind, and the types of clouds are all described in a weather report. So our new vocab in this paragraph, meteorologists, comma, and then the definition. Box, comma, underline. Box, comma, underline. That's going to be our motto for this bit of reading here. And so this is just a further description of what a meteorologist does. Weather changes each day because the air in our atmosphere is always moving, redistributing energy from the sun. In most places in the world, the type of weather events expected vary throughout the year as seasons change. While weather can change rapidly, climate changes slowly over decades or more in response to changes in the factors that determine our climate. So, as we read this, we might have seen this word and not really known what it meant. I'm sure we probably have heard it before and we can kind of guess what it means, but just in case, we're going to write moving around, and that's our alternate definition that we could replace that with. The air in our atmosphere is always moving around energy from the sun. And that's kind of our very brief, simplified definition for redistributing. And then we have a bit of a compare and contrast between climate and weather. And our definition for climate will come in the next couple paragraphs. So we won't box or circle anything in this section. All right, the sun's effect on Earth. Energy from the sun is very important to the Earth. The sun warms our planet, heating the surface, the oceans, and the atmosphere. The energy to the atmosphere is one of the primary drivers of our weather. Our climate is also strongly affected by the amount of solar radiation received on Earth. That amount changes based on the Earth's albedo. That is how much radiation is reflected back from the Earth's surface and clouds. The amount of radiation given off by the sun changes with solar activity, like solar flares or sunspots. Solar activity is known to vary in cycles, like the 11-year sunspot cycle, and longer cycles. Sometimes scientists have wondered if changes in our weather and climate might be linked with short or long-term solar cycles. Weather is the current atmospheric conditions, including temperature, rainfall, wind, and humidity for a given area, while climate is the general weather conditions over a longer amount of time. This has been an active area of research for decades. It is an example of the scientific process. Okay, so let's go back to our first paragraph here. The sun warms our planet. This energy to the atmosphere, this sentence right here, this is our key takeaway sentence. This is what, or our key concept sentence. It is exactly what we are getting at. That's going to be our topic of study for the next couple of days. That the energy to the atmosphere from the sun is one of the primary drivers of our weather. And we're going to learn exactly why. Our climate is also strongly affected by the amount of solar radiation received on Earth. Solar radiation is the next word that we're going to box, but it's not defined here. So I'm going to do a little loop around here and define it over here. Light or energy from the sun. Light or energy from the sun. And the light or energy received from the sun changes depending on the Earth's new vocab word, albedo. Albedo. Circle that. And it is how much radiation is reflected back from the Earth's surface and clouds. So if you remember from the demonstration, the shine of the light on the surface of the stress ball, then that reflectivity, or the amount of reflection off of that surface, was the albedo of the object. And so everything has an albedo, an amount that it can reflect back. But in terms of the Earth, that is determined in some part by the surface and the clouds. And then we look to changes in solar radiation activity, and we go down here. We've already defined weather in our previous paragraph, so we're going to define climate now. Climate, we're going to put a box, circle, underline. Climate is the general weather conditions over a longer amount of time. And it might seem elementary or juvenile to kind of box, circle, underline our definitions this way and to show what is going to tell us what definition is. But it's just part of good practice to keep annotating and making sure that we are seeing how to find things in the text. Especially as we get into high school, we got to be able to find that evidence and find the information from a text on our own more than sometimes these graphic organizers or the teachers can help you find them. These are the tools that we should be looking for on our own. So we just read our two passages, and we highlighted some of those special vocabulary words. And here I've listed the most important ones that we will need to know before the next assessment and before the entire unit assessment. And finally, we are going to answer the prompt for what features on Earth might increase its albedo. And we just defined albedo above, and I asked you to write 2 to 3 suggestions and complete sentences in the space below. So those 2 of those suggestions are written in the text, and there's also one other surface that might increase the albedo of the Earth, and I want you to think about especially the poles of the Earth. What might increase reflection of light? Okay, I hope this was a helpful lecture. If you have any questions or comments, feedback, please email me at schultzscience@gmail.com, and I will see you next time.